It's time for SQL Server 2019 Intelligent Query Processing. This is going to be a 30-minute cameo. In this virtual symposium, there's quite a bit of intelligent query processing features that are being covered. I am going to do part 1, which is 30-minute all demos, and I'm going to cover table variable deferred compilation. I'm going to talk about and also demo the memory grant feedback feature. My colleague Satya, who is going to do part 2 of this, is going to cover adaptive joins and batch mode execution on row store. My friend Uwe Ricken from Germany, who is also a speaker in this virtual symposium, is going to cover interleaved function execution and inlining execution with scalar user-defined function. So quite a bit of query tuning improvements in this umbrella and family of features called intelligent query processing. So with this part 1, 30 minutes, that's all I have. So no slides, all demos. Let's jump into the demos. My name is Amit Bansal. I am a SQL MVP, also a Microsoft Certified Master of SQL Server, and Microsoft has also honored me with Regional Director status. But more important than that is I'm working with SQL Server since 1997, and SQL Server is my first love, and my wife doesn't mind that. And yes, of course, countless SQL deployments over the years, a lot of trainings, consulting, and content development with more than 200 customers worldwide. My community work is Data Platform Geeks, SQL Server Geeks, and Data Platform Summit. And you're part of this virtual symposium, which is by Data Platform Geeks and SQL Server Geeks. On work front, I work with SQLmaestros.com. We do a lot of content development, video courses, learning kits, hands-on labs, ebooks. So make sure that you visit SQLmaestros.com and you explore all of that. You can follow SQL Maestros on Twitter. That's the Twitter handle there, or subscribe to SQL Maestros newsletter. So the bit.ly link is right here. And of course, do not forget to subscribe to the YouTube channel. Apart from all these sessions that you're learning here, there's quite a bit of content in the YouTube channel on internals and performance tuning. I am available on Twitter, _Bansal. And if you wish to join me in my exclusive distribution list, here is the URL, bit.ly/connectwithab. All my attendees of such sessions, even in conferences, be it in person or online, pre-con sessions, master classes, people who are watching videos, many of them are part of this Connect with AB exclusive distribution list. And if you like the session and you want to give some feedback, there's another bit.ly link there. So all these links are available in the chat window. Feel free to click and join wherever you feel appropriate. Now let's right away jump into the demo. First, we are going to talk about table variables deferred compilation. So the file is one_table variables, and the scripts are going to be available with the recordings on dataplatformgeeks.com. For the purpose of this demo, we are using our own fictitious database, SQL Maestros. Let's change the database context. Now, before I move on with the demo further, let's discuss a few concepts around table variables. Now, variables are nothing new in programming world. Whenever developers want to store temporary data, they use variables. And variables have to have different data types like string or numeric or date time. In SQL Server world, you can also declare a variable of type table. Let's say you want to represent the data in form of a table. Well, SQL Server is relational world, so there are all good reasons for developers and DBAs to represent the data in that format. So it's a good technique. You can declare a variable of type table, and then you can add attributes to that table variable and give data type to each attribute, again, like character, numeric, or date and time. So table variables are one option. There's another option. You can store the same data in temporary tables, and temporary tables are very similar to the actual physical tables that are there in user database, but temporary tables get stored in TempDB system database. Now, I have seen developers and DBAs preferring temporary tables over table variables, and there are some good reasons for that. Temporary tables support indexes, and they also support statistics. Unfortunately, table variables do not support indexes and statistics. Now, indexes is not really the point of discussion for this demo, but statistics are. What really are statistics? Now, statistics is data about data, and that is one very critical piece of information that the optimizer needs to produce an efficient execution plan. The problem with table variables are that irrespective of your table variable, let's say it's storing 1 million rows, the optimizer is always going to do a fixed guess of one row. So you hear me right, even if your variable has 1 million rows, it is always going to estimate only one row. Now inside the optimizer, there is a piece of code called cardinality estimation. The job of cardinality estimation is to do this cardinality factor, this computation of estimated number of rows versus actual number of rows. So if estimation is 1 and actual is 1 million, and if that is the information the optimizer gets, you can probably understand the optimizer is going to produce a suboptimal plan. This will really affect the performance of the query in most cases, and that is why table variables it really becomes a deterrent for developers in DBS to use table variables, and they resort to using temporary tables even if they have to store less data. Of course, temporary tables have their advantages, but then not everything is always great with temporary tables. Whenever you use temporary tables, you have to run the allocation, deallocation code, and that also is time consuming. But then the discussion is not really the comparison between the two. The point here is table variables are good programming structures, but because of this lack of support of statistics and this optimizer's fixed guess of one row really becomes a detrimental factor. So in SQL Server 2019, this improvement, table variable deferred compilation, is a great addition in intelligent query processing family feature set that helps this. How does it do that? So the key thing here is deferred compilation. So the statement that actually refers the table variable, the compilation of that is deferred until the first execution, which means the optimizer has better information about the number of rows that are there in table variable, and then the cardinality estimation can compute the cardinality factor in a better way, which gives more information to the optimizer, and hopefully the optimizer can produce a better execution plan. With this very quick overview and a very high level overview, let's straight jump into the demo and see how this works. Now, of course, for table variable deferred compilation feature, the first thing that you need to know is your database compatibility level should be 150. So if you're creating a new database in SQL Server 2019, it will be 150. But if you're importing it from or restoring it from a previous old version, the backup, then of course you have to change the database compatibility level. That is one thing. The other thing is there is a database scoped configuration here called deferred compilation TV, which is by default on. Now, both of these things I'm not going to touch right now because SQL Maestro's database is actually in 120 compatibility level. So in this demo, first I am going to show you the behavior of how things were in prior versions, and then we will upgrade to SQL Server 2019 and see the performance improvement. Now, here is a table variable called @tblvar. It has two attributes, download ID and download date, of type integer and date respectively, and we are inserting a few records in this table variable. For the purpose of demo, let's turn on the actual execution plan or press Ctrl M, and then let's go and run this. Now, when I run this, you're going to see the behavior of how the optimizer treats table variable. How is the cardinality estimator performing? What estimation it makes? What is the cardinal factor? What execution plans do we get? And this is like 2017 or 16 or 14, so on and so forth. Let's go and execute this and straight away jump into the execution plan. Let me expand this a bit and take the cursor over this arrow here, and you can see, let me zoom in, actual number of rows is close to 100,000 here, 99999, but if you see, the estimated number of rows is 1. Now this is really where the problem is. This is what we call as the estimation by the cardinality estimator here. Optimizer is only estimating it as one row, which means this information is not good for the optimizer, and the plan which is given to us may be a suboptimal plan. Now, this is always going to be the case with table variables until we upgrade to SQL Server 2019. Now, let's say we have moved to SQL Server 2019 and we change the database compatibility level to 150. Let me do that and execute. Done. And now I'm not touching this option because the moment we upgrade to SQL Server 2019 and change the database compatibility level to 150, because to use these latest features in intelligent query processing family, the database compatibility level has to be 150. So once that is done, the feature is automatically enabled unless you want to turn it off using database scoped configuration. So I'm not going to touch this. I will come back to this later as to why you really may want to do something like this. So I've just changed the database compatibility level to 150, and I will go and execute this query once more. And now it's running in 2019, of course, with compatibility level 150. Let's go and execute this. Go into the execution plan and take the cursor over the estimation here. And now you can see the estimation is quite better compared to what we saw earlier. So instead of 1, it gives me an estimation of 30,000, which is quite good compared to the actual number of rows. So this is the improvement which happens by default. So you see, you have not done any change in the code. The code is same, which is a great thing again, because the code might be embedded in an ISV application and you might have little authority on changing the code. So all that we do is upgrade to SQL Server 2019 and the feature is enabled by default, and table variables get a better estimation here. So cardinality estimator does a good job, and it also helps the optimizer to produce an efficient execution plan. Now let's say that some of your queries are regressing, or let's say this is not really behaving very good for you, and you want to upgrade to SQL Server 2019, you want to change the database compatibility level to 150, and you want to utilize many other good things that 2019 brings, but this feature probably for some reason is not really working good for you, so you can turn this off. And that is where this database scoped configuration comes into the picture. You can say, alter this database scoped configuration deferred compilation table variable. So TV stands for table variable, and turn this off. If you turn this off, let's do that. And then if we go and execute this query again, so even though your database is now in 150 compatibility level, this particular feature is going to be turned off, and it's going to give you the same behavior that you got in previous versions of SQL Server. So let's go to the execution plan, take the cursor over the arrow here, and you can see you have the same old behavior now. Estimation is 1. Now this is a great thing again, because not everything might work as expected, and when you upgrade from an older version to the newest version, sometimes you may get default performance improvement like the way I showed you, but sometimes your queries might regress. So you should have this option of turning a certain feature on or off, and this database scoped configuration is a good knob, so you can just turn it on or off depending on the advantages that you see. So let's go and change the database compatibility level back to 120. And this was table variable deferred compilation, a great improvement, something that the community has been asking for quite some time. Now with this, let's move on to the second demo, 2_ adaptive query processing, where I'm going to show you the memory grant feedback feature. Let's jump to this window. For the purpose of this demo, we are going to use this database wide world importers, and I pronounce this right. It's not worldwide importers, it is wide world importers. Let's change the database context and move ahead with the demo. Now again, before I get into the actual demo, let's discuss a few concepts around the memory grant thing. Now, what exactly is meant by memory grant, and why does SQL Server really need it? For certain queries, SQL Server needs extra memory. The classic examples could be like sorting or hashing. So let's say when SQL Server has to perform an in-memory sort of, let's say, millions of rows, or if it has to do some hashing technique for the purpose of, let's say, hash match aggregation or even hash join, then it needs extra memory. Now, this extra memory is again an estimation that the optimizer really makes, because until execution, it does not really know how much memory it needs. So there is this estimation of the exact data size that it's going to deal with, and that also is estimated based on the row size, and then the total data size that it estimates, it takes about 1.5 times of that. So if you see, there's a lot of this computation that happens which is purely based on estimation, and again, the statistics play an important role here. Now, sometimes the optimizer can make mistakes here. Sometimes it can over allocate memory, which is like over granting, or sometimes it can under allocate memory, which is like under granting. And then the optimizer has this mechanism to fix it. And this is the feature in SQL Server, I think 2017 onwards, which comes under adaptive features, which is again under intelligent query processing. All that is very confusing. But anyway, the larger point here is this adaptive behavior of SQL Server with this feature called memory grant feedback. So what is SQL Server going to really do here is it executes the query the first time, and then after the first execution, SQL Server optimizer learns that, okay, the allocation of memory, that extra memory grant that was done was quite overdone, or it was under allocation, and it has this opportunity to fix it. So this is what we call as the memory grant feedback. It gets the feedback after the first execution and it fixes it for subsequent execution. So this is what we're going to see. So let's jump into the demo now, and we are going to see this adaptive query processing feature, memory grant feedback. And as I said earlier, adaptive joins is going to be shown by my colleague Satya, and then let's say interleave function execution is going to be shown by Uvirikan as part of this virtual symposium. Now, before I go into the database scoped configuration, compatibility levels, and all of that, let me first show you the behavior, the way it was in prior versions of SQL Server, just like my previous demo. So I'm straight away going into this code, which is doing some operation, I mean some join and where clause, and most importantly, this order by that you see here. As I said, that sorting and hashing are classic examples where extra memory grant is required. The actual execution plan is already turned on, and let's go and just execute this and see what is the behavior. Now, when this execution is complete, we go into the execution plan here. And if we take the cursor over the arrow, which is between the sort operation and the hash match join, here you can see that estimated data size is about 4.7 MB or something. So precisely 4707 kilobytes. Now this is the data size, but how much memory has been granted for this execution here? If we take the cursor over select operator, you can see that SQL Server has allocated 86 MB here. So this was really over allocation, much more than was actually needed. Now, if this query, now the way we have executed it, and the plan is cached. So this plan that you're seeing is cached in the procedure cache. And if we execute this a second time, what really happens? Will there be any feedback, any adaptive behavior where the optimizer can learn from the first execution that the allocation was much more than was actually required? Let's go and check this out. So if we go to the execution plan again and take the cursor over select operator here, you can see that every time it always allocates 86 MB. So there's no really learning here. There's no feedback here. So this was the behavior that we saw in previous versions of SQL Server. But now from 2017 and 2019 onwards, there is this memory grant feedback behavior, which is great. Again, you don't need to make any change to the code. SQL Server is intelligently going to learn and is going to adapt based on the first execution. So for the purpose of this demo, and of course for the purpose of this feature, database compatibility level has to be equal to 140 or higher than that, which means 140 or 150. What is the current compatibility level? Let me just quickly go and check this. So the current database compatibility level for worldwide importers here is wide world importers here is 130. So of course, as you see the behavior, after even first execution, subsequent executions were still granting 86 MB, which means the adaptive behavior was not working because the compatibility level is 130. Now, what we are going to do is change this to 140. So I'm going to run this code on line number 25, change the database compatibility level to 140 or 150. Let's go and execute this. It is done. And now again, there is database configuration. And by this time, you already know the purpose of this is that if you are upgrading to 140 or 150 and things are working fine, but you don't want this feature, you can turn it off. So again, this is a knob, just like what you saw in table variable deferred compilation. Let's move forward, which means I can also go and check whether this feature, batch mode memory grant feedback, which is actually the technical name here, is turned on or off. So you have the system catalog here, sys.database scoped configurations. Let's go and execute this. And batch mode memory grant feedback, you can see the value is 1, which means the moment this upgradation was done, it is turned on by default, which means now the behavior should work the way we expect. So let's go and execute this. Actual execution plan is turned on, which means now we are running this query for the first time here. The plan got kicked out when we, of course, changed the compatibility level. And we go to the execution plan and take the cursor over select operator here, and you can see the memory grant is 86 MB. Well, this is what we expect in the first execution. Of course, all other metrics are going to be same. If we take the cursor over here, you can see the estimated data size is again 4 MB or so. Now here is the key thing, the fun factor is when I execute this query a second time, which means after the first execution, the optimizer has learned that the allocation was much more than was actually required. And can it go back and change this allocation in the cached plan? And this is really where the beauty is. So let's go and execute this once more and go into the execution plan and take the cursor over the select operator. And now you can see that memory grant is just 21 MB. So like kind of 4 times lesser and much more closer than to the estimated data size. So this is the feature called memory grant feedback. So after the first execution, the optimizer learned that the memory was over allocated or under allocated, and it learns from that, which is this adaptive behavior, and then goes back to the cached plan and updates the metrics. And subsequent execution will then use the metric which it learns from the first execution. Now again, of course, you have upgraded and you don't want this feature, you can always turn this off. So if you turn this off, the feature is going to be off, and then of course every execution is going to always get the same memory grant. Let's just quickly test that. So I'm going to turn this off now, and from the database scoped configuration system catalog, let's go and verify that. Sorry, it was not selected. Okay, let's go and execute this, and now you can see batch mode memory grant feedback is turned off. The value is 0. Let's see what the behavior is now. So let's go and execute the query. First execution again here. And we go into the execution plan, take the cursor over select operator. You can see it is 86 MB. There you go. And what happens if we go and execute this a second time? Remember when this feature was on, you got 21 MB as memory grant, but now you have upgraded to 140 or 150 compatibility level, but using this knob, you have turned it off. What happens now? So if you see, the grant is again 86 MB because the feature is turned off. Well, these were the two features in SQL Server 2019 intelligent query processing that I wanted to do in part 1, a short cameo, all demos, 30 minutes, and I think I'm well within time. And if you see the advantage, the beauty here really is that you're not making any change to your code. Your code is exactly same. These are great improvements that are done in the engine, in the optimizer, the cardinality estimator, and you get this default behavior. And for whatever reason, if your query is regressing and you're not able to take advantage, you're still upgrading to SQL Server 2019, but you can turn these features off. So this was a quick introduction to two features in SQL Server 2019 Intelligent Query Processing family. There are more that Satya will do in part 2, and Uvirikan will do a lot more in user-defined functions. But remember one thing, this was a quick demo and a quick introduction. You got to explore and research a lot more on these performance features. With this, thank you very much for your time. And now I am ready to take questions. And for those of you who do not have questions, feel free to visit sqlmaestros.com and follow me on Twitter, _Bansal. Give some feedback, how you liked the sessions. The feedback links are there in the chat window. Now over to the Q&A panel to answer some questions. So Satya, let's get started with the Q&A.